So let's say you have a pot there, I mean like a little lake or whatever, and you make the car park there. If the car should be smart enough so it stops and doesn't drive into the water, right? And that's, I think, because if it would happen, everyone would be, whoa, this is super stupid, because also like understanding of AI is like very general, so you know, if GPT cannot say how many R's in strawberry, then it's stupid. But that's not the way to build trust, but that's like a very easy way to become not trusted.
So, Janek, you work at Sano in one of the teams, extreme scale data and computing. You are a senior programmer.
Yeah, I mean, a scientific programmer. I'm too young to be senior, you know?
What does it entitle? Like, what do you do?
Recently, I realized like that when you're a programmer, usually you do more code than I do. So there are a lot of things that I do except coding, but coding is easier to explain. I mean, the things that I do. So what I'm programming is basically all data workflow, and which is followed by AI, obviously. So for anyone who ever did it, actually building an AI model when you have prepared data set is super simple. You have many tutorials for it and it's straightforward. Then understanding what's happening underneath is more complicated, but also doable. If you have some math background and so on, that's sometimes like very straightforward. But there is a lot of work in between. So you have to understand what you're doing. And what I mean by that is that when I work with brain imaging, at some point I'm a little bit of a radiologist. I mean, I have to sometimes like see that model for this particular case always is wrong.
So hold on. So you are engineer.
Yes, let's call me like this.
Good at math.
Yeah.
But your work demands that you also understand medical aspects of the data that you work with, right?
I mean, that's not mandatory. I imagine I could be doing it without, but then I always have to ask someone about it. So, you know, it's like a side effect.
Right.
You're reading all these reports that I don't know how to call this diseases, neither in Polish, Latin, or English. And then I finally learn all the names in English because I'm reading it again. And then I realize, oh, every time there is, I don't know, a lung nodule.
Yeah.
There is something happening there. Or like a glioma second grade. And I discovered that there are grades. And if you know, you keep digging. Sometimes you just like don't pay attention to it. But then when you have an issue, you sometimes need to understand, or when you want to describe it to actual doctor. And I think actually when you don't ever try to understand it, you are working like on very low level.
Yeah.
You are kind of
blinded.
Like, yeah, you are kind of like AI coding, you know? You are like, okay, it works, but you don't know why. And if you would to be present to it someone, I mean, there is no communication, you know? There's like a different language for you. If you ever like meet a doctor, because that happened to me, and you want to talk with them like what you are doing, they have their own terminology. They are studying for 6 years and basically learning all these hard words, and like you cannot talk with them, and that's a pity. I think communication is needed.
And so it's kind of common language, right? That enables this communication to be, fruitful for both parties.
Yeah, exactly.
But I guess that your path and what you're saying that, you need to understand to be better at developing tools, AI models, understanding medicine. It's not mandatory, but it's sort of needed, right?
Yeah, I mean, if you do it for longer, it's not like someone asks you like just do AI on it, and it's like super well prepared. I mean, I imagine a scenario that you don't understand it and it works, but that's a little bit of unrealistic.
So this is something that for me is super interesting. that I think that the success of AI in medicine is created in this ecosystem that can use common language. And that common language means that people from very different disciplines that were sort of, working on their own ideas, so doctors, engineers, come together and then can cooperate around one project. And with that collaboration, you've got that synergy that allows you to develop something better than just a tool that could be useful or not, right? So that collaboration is needed. And you work with very specific data sets, MRI scans. Would you tell us a little bit more how you understand MRI imaging and CT scans? Like, what are they for you? Why they're important in your work?
When I came to Sano, first I was like seeing all these images, and it's like everyone knows how brain looks like, I don't know, from a cartoon or whatever, but actually it looks like this. And then you realize, first thing that I realized that this is just noisy. And you have the nice ones, so like when you have like a visualization for, I don't know, some biology or something, it's just very perfect, like perfect from the
anatomical point
of view, but as well also like perfect from the quality of the signal you got. Because imaging is acquiring the signal, so like a perfect picture, a little bit like AI generated picture of the brain. That's what you get when you are in any terms of education or so that's the first thing that you see. So the brains, the imaging is very imperfect, and you have artifacts there, there are like, I didn't know how many different things can happen in the meantime. So for me, you see the brain and you can understand okay, that might be the skull, here there were eyeballs and so on, because you'll see it, all of this on the brain, because all of this imaging, what's tricky is 3D, and we don't have a nice way of visualizing it. So at the beginning, when you just look at one slice, because the technique is to look through the slices, the problem is that when you just get an image, I cannot tell where am I, and where is front and where is the back. And so I know radiologists do, but especially here, like in this lungs area, sometimes you don't belong the lungs, and then I have no idea what I'm looking at. Good that we have spine, so like a spine is the reference point, but still sometimes I need to figure out, okay, this is the spine, so this is this, and like it's a lot of like abstract thinking where we are. And also without the reference of going up and down, you cannot really tell usually.
So that was the problem, to kind of imagine where you are in this cucumber that is sliced, imagine it as a whole.
Yeah, that's for sure something challenging.
And when you are working on this kind of data sets, so for lots of people, generators and transformers are quite good at analyzing images, right? We've got ImageNet, got computer vision. What's the problem with AI and analyzing images in medicine?
Yeah, what's the problem?
Yeah, exactly. What's the problem? You've got them. You could clearly say, right, this person is sick. This person has got something here. Yeah. Let's operate on it. So
yes. So why we are not using it yet? That's the question.
Well, from the point of view of FDA approvals, we can see that most of the tools using AI are in radiology.
Yes.
But still, if you start looking for precise examples in hospitals, it's not that many that's been... They are approved, but using is a different thing.
Okay, yeah. The main reason, and that's like, obviously it's like, we need to adapt, it's a system, it needs to be double checked and so on. That's something obvious because, from the technological point of view, we are like very ahead. We could be doing a lot, but especially in medicine, I think it's hard to implement. So that's one thing. We can be talking more about this, but I want to jump to another thing, which is responsibility, explainability, all this.
And trust.
Trust, all this, let's say, buzzwords, but actually very important, especially in imaging, because, as I told you, first of all, the images are noisy. So you don't know really if it's like the guy has some defect in his brain or it's the scanner's fault. So, your AI can be fooled by it. Then you have like all the aspects that, okay, it says this guy is sick, but let's say like on another side, because there are different modalities, but we have either an image or a text. And when you have text, someone is describing like how do you feel, what are your symptoms, and so on. You can say, okay, this is the symptom responsible for this, and you can see like a clear logic there. But for imaging, it's like way more abstract. Like, it's like in the right lung, which is also a little bit smaller, you have like some spider web-like tissues. And okay, I described it now in words.
As soon as you do it in words, you are less abstract.
Yeah, exactly. Let's imagine broken bone. You have everyone's in it, right? Like you have a broken bone, you can imagine how it looks. It's pretty obvious for us to say, okay, this bone is cracked. Sometimes it's not visible, but if there's a doctor pointing for you, like for the crack there, we can understand that we've seen a broken stick, we can see, like, kind of talk about it. But then try to describe it to like a computer, like what does it mean in terms of like pixels, because that's what image is. That's hard because the crack is like a line, but actually not a line because it's a little bit cracky, sharp, and when the line is like next to the bone, it's just like a line, but it has to be going through the bone a little bit aligned with the bone itself, but actually sometimes not aligned because you have different types of cracks. And I could be talking here a lot, like how complex a bone crack can be. And that's so simple. We have just like an X-ray, technology which is super old. And then think that you have a brain scan, or let's go with CT, because these are like multiple X-rays. It's more complicated just because of the bigger volume. And then think it's not just bones, but like brain, which is something super complicated.
But okay, so if we use this analogy to transformers,
we are talking about deep learning transformers now.
Yes, so they needed the change in the logic that you cannot, brute force all the descriptions, but you've got this attention mechanism that allows to predict the next word and generate the text that is coherent, and therefore we can have a discussion with machine. Would that mean that we also need a kind of revolution in the way we train models so they understand medical imaging better? And would that also mean that we need to use it for specific organs or tasks? So for example, brain, lungs, heart. And then that would maybe be a little bit easier.
So the promise kind of AI is that we'll get smarter and smarter because we have better technology, and you don't need to simplify the things, you just need to create better AI. That's the promise. But I can tell you for sure what you shouldn't do, because you can distinguish maybe like that's for analyzing the brain.
Right.
And that's for analyzing the lungs. You shouldn't distinguish that's for analyzing brain tumor, because I think that building the trust is also about being a more general, in the sense that if you have any another malicious or just benign abnormality there, it should be reported. So, we all know that you have very nice AI models for outlining where is the tumor of the patient, and that's useful. But that's not like replacing the doctor like at all. It's like first it needs to be diagnosed and so on, and then if the doctor needs it for some kind of visualization, he can click, and that's the application of it. I mean, but here we see a bigger potential than just like for the doctor for some kind of visualization for the surgery and so on. I mean, that's what people are saying, that we can actually, the discussion is about helping the healthcare system. Like, I don't want to say replacing the doctors, because that's something that I think
make the work more efficient.
like release the workload and so on. So here I think the promise is bigger than just saying where it is. So to build the trust and to actually make it like functionally on a bigger scale, not like for very specific cases, for sure AI should be like across all the possible abnormalities. I mean, to not skip when you are diagnosed for something, because then you don't have cancer, but you have something else. Or let's like.
No, I was thinking about more organs rather than diseases.
Yeah. Okay. So, but also when I think about organs, when you do CT, and it's actually, I've heard about a few cases that you want to look at your lungs, but actually on your thyroid you get something. So it's very useful to actually have a look at the whole anatomy, and sometimes I don't know, maybe your liver is bigger, so it makes your lungs smaller. The lungs are
what good radiologists.
Yeah, exactly. I mean, also like good radiologists would see that like the stomach is a little bit bigger than it should be. I mean, like the liver, let's say, and it's pushing the lungs. I don't know if it's possible from the anatomical point of view, but you get my point. So simplifying the task, it might be a dead end, because you want AI to actually build trust. And if you have like sub-task AI, I would call it, you will like, I know,
Janek, but if you give yourself a really big problem, you cannot reach it straight away. You need to put it in steps. So what I'm saying is that maybe rather than promising that we can understand the whole body, we should think about, for example, different organs and then put it together. So it's like you creating tools or a platform, and then on that platform, you join them together. Because if you want to do everything at the same time, you can't.
That's true. I agree.
Somebody told me, what do you do when you want to eat elephant?
Yeah, I know. I know.
You cut it into pieces.
Yeah.
Why elephant? Okay, I don't imagine eating elephants. But that's kind of, it's stuck in my head as a metaphor of addressing very complex problems that are about a system. So if you think about human organism, it's a system that is connected to other systems, right? Outside and inside the body.
I agree with you.
I hope. But
I mean, here we should be, maybe a little bit.
No, we should fight.
We should fight a little bit. It depends. In general, I think if you have a task where it's because you are now talking more from as an engineer, you are saying how to make it work.
Yes.
And your answer is like, start simple.
Yes.
And that's good. And I agree. But here I was answering in terms of like how to put it in work. So how to build the trust. I mean, let's stay with the trust. And I think trust is needed because we as humans are like, okay, it's a system to detect lung nodules. They can be benign, they can be like just to observe and so on, but it didn't detect a cancer. And let's say you have a situation that someone had it and like no one noticed that there was a cancer. And we humans are like, this is unforgivable. I will never use AI. And like,
so let me put this way. So you are associating trust with ability to show efficacy of a system on a whole scale, like whole scale meaning whole body.
No, it doesn't have to be whole body, but if you're for imaging, medical imaging, if you get brain imaging like MRI, and even someone has something, with MRI, sometimes you see the neck. And if you spot something in the neck, it should also spot something in the neck.
I don't know. That's kind of very ambitious. So if you have an MRI...
Okay, that was ambitious with the neck. But if you have something in the lungs, around the lungs, you have so many things. The heart, the thyroid is like right here. And sometimes they, they work together. So sometimes, like, let's say, swollen thyroid makes your lung, makes you breathe worse, and then that's a scenario. Then you go for some examination. They say do CT of your lungs, and the lungs look healthy. They're a little bit reshaped because of the swollen thyroid. I don't know if it's possible, but I'm just giving a scenario. And then let's say the system doesn't tell you that because there is nothing in the lungs.
The system, right?
Yeah, the system is like not seeing anything, and it says nothing in the lungs. Job done. You don't have to come again. And I'm thinking from this perspective that it has to be
something. Yeah, okay, I understand this. This is something that it's definitely not the mainstream of understanding trust in AI as it is right now. Because right now, the trust in AI you do not create by waiting till your tool is good enough to be deployed and say, okay, it can recognize pathologies in the given region. Right now, it's a little bit trying to make it transparent for certain users. Yeah, for certain users. So it clearly would, for me, it would be enough to clearly understand what the tool does. So it needs to be explained.
And I think that's also very important. Yeah. There are like few things you can do to build the trust, and explainability is a big thing, hot topic, but I want to also highlight this because that's like
efficacy you're highlighting, the trust that comes with efficacy. So I promise it does certain thing, and you're saying, does it do it? Yeah, exactly. So if you have like a car that is supposed to park by itself, right? Yeah. They are doing it already pretty good. It parks, like spins your wheel and so on. But if, let's say, there is a huge hole, let's say like actually a cliff or like something a little bit more tricky. So let's say you have a pot there, I mean like a little lake or whatever, and you make the car park there. If the car should be smart enough so it stops and doesn't drive into the water, right? And that's, I think, because if it would happen, everyone would be, whoa, this is super stupid. Because also like understanding of AI is like very general. So if GPT cannot say how many R's in strawberry, then it's stupid. But all these tricks. So my point is like, that's not the way to build trust, but that's like a very easy way to become not trusted. So yes. You need to take care of being not trusted, because that's like an example that will be with you for all the time if you are building it. And so two paths, like explainability, but also being like just smart. To be smart, you have to understand more than just the thing you were trained for. When you say it this way, I trust that you're doing a good job, and I'm sort of happy that people like you are doing the work, because that's very ambitious, and that's kind of, looking a little bit ahead of what's gonna happen. How do you understand smart? How do you understand intelligence?
Ooh, I didn't expect.
Yeah, I know, but that's like,
question. I can think about it.
If you're putting this answer to trust like that, then I would be curious. You say, be smart. What does it mean to be smart?
Yeah, if we're translating this to AI or deep learning, I think it's like generalization. So go a little bit beyond you've seen.
Sure, absolutely agreed, yes. With very little, you can do a lot, right? So that's the generalization, dude.
Yeah.
That's what a smart person.
Yeah. So like you don't have to be like before, let's stay with this example, parking in a place where there is a water trap, to be smart enough that the car will drown, right? So you've been parking, you've seen water, so don't park in the water.
Like the dots, right? Yeah. No, I understand. I think that we covered quite well the trust issue. That's interesting that you frame it this way. Let's go to my questions again.
It was also...
Yes, this one. In medical imaging, how do you think about the trade-off between model performance and trust? And you said that you've got a story when I was in Oxford.
I've got the story. I mean, because that's about medical imaging, and that's what we've talked about, that text is easier. You know, you can build some logic about it. Someone has runny nose and a fever, that's a flu, coughing, and so on. But with images, it's more abstract. And nowadays, the way to build explainability is to ask the model, and you can actually do it pretty well, what is the area of pathology. So Mark, like, please show me, if it would be like a doctor, show me with your finger where on this image you see a brain tumor. And that's easy in theory, because that's just easy, let's cut it here. And that's the way to build the trust. But does it make you convinced that you can trust it? I mean, that's just pointing to the place that looks abnormal. Is it enough to convince you?
If it's a benchmark confirmed by the clinician, I can treat it as a ground truth.
Yes, but when a doctor does it, the thing is, he points here and he can tell you a little bit of a story, like
why.
So usually this is bigger, usually this is not inflamed, usually something. So
rather than pointing only, you've got the explanation.
So there was this summer school in Oxford, and there was a professor from UCL. She did a lot of brain imaging as well, and basically was saying the story about that, basically what I said. So I was paraphrasing her, that pointing is very nice and we are happy that it works, but it's not enough. I mean, we want more. Obviously the question is, what's the follow-up? I mean, what else you can do on the image?
Yeah, this reminds me of what Andrew Nag said. So he is very good at not only coming up with AI solutions, but also implementing them. And he said that in one of the projects, they created a tool that was giving some hints around analyzing images. And the doctors were not that interested. So it was doing what you're saying, kind of pointing. So they did research and they quickly discovered that the doctors were saying, well, we don't know why this answer was given by the model. So they made another kind of version. And in the user interface, they made possible that you go inside the tool and you see what kind of steps were taken and also what was the fault chain, let's say. Okay. What was the process? So it was explaining why it gave this answer. And he said, it worked. All the doctors said, like, that's fine. They checked it, but only once. Because in their head, when they were asked again at the end of the project, so why you said you wanted it, you checked it once, then you were not interested. And they were like, because we know that this way of thinking is already in the model, we don't want to check it. We started trusting it because it sort of thinks the same way as we do, right?
Yeah, you don't need to build the trust only for the patient, but also for the doctor.
And this is, I think, more important than question about trust is for whom and what in what kind of phase of the development. So is it for a clinician? Yeah. Is it for somebody who is auditing the system? Is it for somebody who is certifying it? And because of this, you cannot just make everything transparent at the same time. You need to know for whom, because also these people will look for different kind of indicators that this works.
When you were talking, I had this thought. Also, another conference, a very nice guy, I don't remember his name, from Stanford University. He was both a professor and radiologist, and it's a whole conference for medical imaging, Mikai, and everyone is presenting their work, showing nice numbers, how amazing their segmentation is. And then he says, actually, like, in my opinion, his main clue was all this, like, we don't need it. I mean, he pointed, he wasn't just critics, he said what is needed. And I think that's like very useful, because I feel most of the things are not going this direction.
The value, creating value?
Yeah, I mean, like, the research is not focused on the things he said, and he's like clearly someone acknowledged. And so okay, to name the things, to don't make it a secret, he said, for example, report drafting. I mean, and that's something that is there, and I think that's a useful tool, and it's possible to do from technological point of view, but no one is really putting as much attention for it as for segmentation, let's say, or as like for any building foundation models and so on. That was like a big topic on this one. My point here is that you have to listen to the doctors, but also like the research in general, they go for what research wants to go, kind of. Sometimes it doesn't go exactly for what's needed.
For what is practical.
Yeah, exactly. I mean, because at some point it's going to be helpful to use them, but we have technology probably ready to do the report drafting. And also what he said, and that's going to highlight another thing, why is it not done? He said progression, because so often you come and you see, like, you've heard at the doctor, this doesn't look good, please do some kind of imaging, or come again in 2 weeks or something. That's how they observe. And this is tricky because we need a ground truth. I mean, we need data not only for training but also for validation. And what's the ground truth of report generation? Okay, sometimes you can connect it, that's easier, but what's the ground truth of progression? Like, very often you don't get what happened. Someone had 2 scans, but the other guy had 6 of them, and how to put all those together. Someone had one and just died,
right?
And actually you need the information that they died, but probably you don't even know, and didn't have the scan of him dead. Why to scan someone that is already dead? So
that actually touches a little bit upon memory, right? So you can relate, so the model can relate not only to the ground truth and foundation model, but to the particular data that's been provided previously, and some understanding was there, and now after 6 months we've got something else, and to compare it in a dynamic way, not to make decision on one set of data, but on the continuity.
Doctors, they just work differently than just look at the scan. That's why it's I think far away from like just create a whole pipeline that is substituting the doctor. And here also I think also from technological point of view, and also when you have a segmentation task, it's easy to measure, easy to compare. You can say that yours is the best and so on. And like, for example, for the progression, I think it's technologically more complex to build it, but also to evaluate it, and just a lot of work should be there done. For sure, there is some. I know also some, but my point is it's way easier to compare and to evaluate others.
So what do you think is the difference between the models that perform really well in research and those ones that perform really well in clinical setting?
I wish I knew a model that I recognize it as a research first and then seen its whole path, like, to clinical use. But the distinction there is not only the edge cases, but just expanding it, because the classical pipeline of building any AI is you have some data, you look for it, okay, it's usable, but you obviously cannot look through all of it. That would mean you have too little data. So classical pipeline is you take the data, rearrange it like make it kind of prettier so it's easier for AI.
Label it.
Yeah, label it. No, I mean, hopefully you have it labeled, but yeah, we have prepared. You have data set prepared, and it barely happens. I mean, it started to happen because of deep learning, but I can speak on it in a second. But you just always do some pre-processing. So make it prettier, normalize. I don't know, for brain imaging, remove the skull because we just want to look at the brain, and so on and so on. And then you train your model. You know, it only sees this beautiful world. It's a human that only lived in a castle and so on. And then a princess.
And then reality hits.
Yeah. And then they ask the princess to go do some groceries and then drive a car in a traffic jam, you know, and then beat on time, even though the traffic jam is there and so on. So reality comes always. And even if you try to avoid it, it's going to be another reality. And, you know, we humans also fail when a little change is there.
Are you trying to say that the scientific word is more ideal,
It's
like
a castle.
yeah, and then reality is messy, right?
Yeah, it's messy, and like a good practitioner, a good doctor maybe fails at first, but like first we human notice that something is different. Like first we notice, okay, now it's going to be tricky. Now I don't see half of the brain because someone sneezed in the middle of the scan. So basically making it from research to clinical, it's super long way, and the truth is there that always there's going to be someone who changes things, you know, or like a thing that happened recently, right? You have a new disease that most of the globe had, like coronavirus, and then what's your AI supposed to do? That's why also I was talking about the trust with being general. And the thing here with deep learning is that previously we wanted to make the data so perfect.
Symbolic AI?
No. So I'm comparing now machine learning with deep learning. So with machine learning, it was weaker, let's say. So we really needed to normalize the data. It was like super fragile to any inconsistencies and so on. It was an art of preparing data sets. But deep learning changes it, and it's like, yeah, let's throw in how it is and let's hope it will make it. And that's making it maybe a little bit more careless, but that's such an advantage because then you have way less work to process the data, think about it. You just, you know, create a monster that will handle anything, and the monster is scary, so maybe.
No, monster is good. Monster can be good. And generative AI, so if we've got deep learning and then at the end generative AI would enable to create synthetic data easier or improve that pipeline a little bit more?
We have radiologist at Sano, you know him well, and the other day he was doing a test for classifying.
He was talking about that, imaging.
Yeah, imaging. So maybe it's in another podcast. Did you talk about it?
Yeah, we did.
Yes.
We did talk about that.
Yeah. So,
but what's your intake on? What's your kind of
story about it?
Yeah, story about it.
So I came to him. I wanted to ask him questions, but he's doing it, and we small talk about it. And then he scored like 80-something% on it. So I would say it's quite good, but he said, actually, in my opinion, it's quite bad because I misclassified, but you know, I'm also not trained for it and so on. And then I said, okay, let me do the test. And at the beginning, I was like kind of bad, you know, like 60% and so on. But then I started noticing things. So, and also he taught me.
Yeah.
And in the whole test, there were like a little bit less than 200 cases. I didn't do it all, but you know, after 20 cases, I started improving, and then after like 50 cases, I was like 77.
Perfect tool for education.
Yeah, but my point here is that, you know, synthetic data for a guy that was looking first time on like X-rays was for me like easy to like distinguish after some point. So we're not there yet, in my opinion, because sometimes the minorities, you know, the bone structure,
something is off. It's not.
Yeah, something is off, and unless you don't fool radiologist like that he scores
99%.
I mean, actually,
That AI.
yeah, exactly. So then I think we're not there yet. I mean, especially also radiologists, you know, he works at the hospital, he knows his scanner and so on. So
He's got the feel of how it should look like. Yeah.
for sure it can help scale because, you know, sometimes you just have to start with something, you know, pre-train the model and so on. So for sure it's a help, but I know even though we got very good in it, it's not there yet.
So the stakes are high. We are still not there. But are you optimistic about progress of AI at all, or?
I actually think it can do a lot on two things. First of all, like not even AI, but just technology can be super useful. We just have a lot of things that haven't been used yet, and I think they can be start to be introduced, and you actually see some maybe positive things also in Poland. I think that's a nice thing, and that doesn't need to be AI. Just like use what we've got since 10 even more years, and it can be super useful, also helpful for the doctors and so on. But that's like a system change, and that's clear. Everyone knows it. It doesn't have to be AI. But then when you're hearing about all these discoveries that actually AI did outside medicine, you know, like some math problem that was for decades. And
37 with Go, right?
Yeah. I mean, also, but I mean, you know, there was a research problem. I mean, obviously someone needs to define the research problem and so on, but yeah, that's a story that these guys were like decades solving a problem. And somewhere in London, I think Imperial College. And then they didn't publish it yet. This co-scientist AI built by Google did it in 48 hours. And the guy who was working on that was, okay, Google, you had access to my computer, right? Because they gave pretty similar solution, but they say no. So we either don't trust Google or we trust AI. So, but my point here is that when you see, because, you know, it's a philosophical discussion, is it thinking, not what's intelligence, but when you see its capabilities. And I mean, we are at the stage that you cannot say it doesn't have any capabilities. It can sometimes discover something and so on. So when you think how much you'd be able to discover on like a state level, so, you know, that should be healthcare system of a whole country or maybe multiple nations, there's huge potential, but that's a long way. And I'm optimistic in a way that this will work. Like if we build it, I don't know what are the consequences, but I'm optimistic in the sense that technologically it's valid and it's a lot to explore.
Yeah, I think that in medicine, well, there are lots of risks and there are lots of things to improve. But because you've got not only, you know, messy reality, but so many different modalities of data.
Yeah.
We can use AI to bring holistic picture again of a human.
Yeah, human is not capable of doing it.
Yeah, exactly. So that's, but you see, we I think that what is similar to our thinking is that we use it even mentally as a tool, right? So we put it in this kind of whole idea of examining a disease or stage of health of a person as a specific application, let's say. It's not like, I wouldn't say, oh, yeah, it will replace humans and will give answers to everything. I think that I don't even know if I want that.
Yeah.
So make it kind of incorporate it in a way that metaphor for this would be like a good quality steak. So you've got red meat and then you've got some fat, but it's so discreetly distributed around the whole piece of meat that you can't separate it. You need to fry it and eat it all.
Yeah, I see. Yes.
If you were advising a team building AI for medical imaging today, where would you tell them to focus and start from?
Obviously it's data, but that's like something kind of trivial, right? I mean, AI is based on data, but set a goal, long, distant, but also like milestones, like, you know, like direction, because Okay, like the longest distance goal is like kind of easy to set because it's something that has to sound nice, you know? Probably it's something for a vision for investors and so on. Just say what's the actual technical goal and how you want to do it. Because usually when you start, I mean, especially the hard, like kind of R&D projects, you don't know how you will reach it. You don't know if it will work. That's the whole point. If you would know that it will work, someone would already do it. Obviously, that's something you should do as well. Check if someone else didn't do it. And if they did, maybe it's still valid to do it, but check how and so on. But like, be aware of like the direction and that's a little bit like, you know, like on the sea.
Yeah, you need to focus on
But also like on the sea.
North Star.
Yeah. Oh, yes. It's good when there are stars, you know. But when it's cloudy, I want this to be a little bit more dramatic. I don't. Have you ever been sailing?
Yes.
Okay, I didn't. So correct me if I'm wrong. But sometimes you just know, like, use the bussola and know the direction. But even if you wouldn't have bussola, like you can kind of think where you are going and like just think about it, because if you are just going somewhere, you can be speeding around and that doesn't bring you anything. And sometimes you realize that, oh, I was going north, I should go west, but at least you didn't spin around. I mean, the thing that you moved north like brought you to a place where you see some sort of whatever. Just like find a reference point like of your progress of what you can do. So that's the. And to have reference points, you need to do pre-research, like kind of properly and so on, and also be monitoring what's going on, you know? Mm-hmm. If someone is not trying to, I mean, it doesn't have to be a race, you know? Sometimes you might connect or be friends or whatever, but it should be, you know, like sailing. Be aware what's the direction and like how you will get it.
I have got the list of questions, but I'm going to start with those ones that were generated with my assistant. So here we go. First one is this. If missing MRI contrast could talk, what would they say? Please reconstruct me.
Oh, so there are answers I can choose. Okay.
B. You're overconfident. C. I was clinically important the whole time, but not now.
C. I was clinically important all the time.
So
why?
Why wouldn't you do the A? Please reconstruct me.
I mean, because that was an intuitive answer, but you know how it is. Like, I don't. No, fair enough. Like, short answer for this. Long story is that doctor, they will manage somehow without, you know, we are humans. We don't have food, we survive. We don't have another modality, we manage. And I've been on a surgery of a brain and I've seen managing without tools. So I think that's our superpower. If we miss something, we still manage. So I was about to say A. After you said B, but then C came and I was like, okay.
Yeah, I got you. You know, I think that actually how you say it now, I can understand that the tools are secondary, right?
I mean, sometimes it can be necessary, but, you know, imaging is just a part of the process. So then when you are following it with a surgery will manage. If you want to have a diagnosis, probably that's not the only modality they have, because we are here probably talking about generating an image from another modality, what I did. Mm-hmm. I don't want to devaluate my work here. Obviously not. Absolutely. Actually, that's what you also say. I mean, we said in the abstract, in the introduction, that generating another modality is for doctor, but also a lot of times for the systems. So sometimes you just need anything, you know, like, because we humans manage to survive with this additional, I don't know, contrast or additional imaging. But when you have like an automatic system, it doesn't get it. like, probably it will not work at all. Probably it will say, please fill in this data missing and what you can do. Probably you just close the program and try to do it yourself, right? I mean, the surgeon, whatever.
Suppose you had to explain brain imaging AI using only one metaphor for the rest of your life. Very dramatic. Do you choose A, microscope, B, translator, C, cartographer, D, detective?
I think I go for my own answer because it's 3D. Microscope is not 3D.
Yeah.
Detective, it's very abstract.
Yeah.
I don't want to go for a person because imaging is imaging, So what was B?
Translator.
Then I think a translator. It's translator. Yeah, okay, translator. Because you're translating between like physical reality, biology into That's also not so metaphoric. I think I'm being like too
shows
precise.
Who you are, this test. Okay, the last one.
It's a personality test, then.
If you could ban one sentence from all medical AI presentations, would it be: the model generalizes well, B, this could transform healthcare, or C, real-world validation is future work?
A is the least candidate.
Right.
Yeah, I feel like the C is always there. I mean, you are like, oh, that's very interesting. But C is a little bit like expected. I mean,
the validation, right?
Yeah, the validation is, especially in research.
It's obvious.
Yeah, it's obvious. I mean, and sometimes even they don't say it because it's, not only too obvious, but also too complicated to do. So if I have to choose one, that's B.
This could transform self.
Yeah,
it doesn't mean anything, does it?
I mean, especially like it's just we are nice. Exactly. Let's keep working. I mean, good to encourage, but
I got two more questions. Imagine an alien sees a brain scan and says, "So, this is a human brain." What is your shortest, honest answer? A, not exactly. B, only partly. C, it's a very useful fiction.
Yeah, very useful fiction. Yeah, very useful fiction. Yeah.
So you work with fiction, really?
You got me. I mean, I would say, again, like another answer, it's like very useful simplification. It's best we have.
Yeah.
Dear alien.
If you had to choose one impossible superpower for healthcare AI, would you pick A, never hallucinating, B, understanding context like a clinician, or C, knowing when the data is too messy to deserve a confident answer?
C is nice. That's a little bit what we talked about. All of them are nice, but C is nice. That's something they measure a lot. I mean, all the big companies building AI, like the refuse rate when they don't know. And I think it's a little bit hidden there. So if you don't know, just don't, don't like people who always answer.
Yeah,
so
always know.
Always know, even if they don't. So I think the third one is a little bit like this. If you don't know, say it. And if it would be like 100% sure, I think that would be like build such a trust and it would be so helpful. I'm telling you, if there would be a system that has like a very good, I don't know, classification. So let's say they say you're sick, you're healthy, I don't know, and it's like never says like.
Dominik Stosik said the same. So I am, and he also said that the model shouldn't be too nice if you are using natural language and you're trying to force it to see your perspective and you not 100% sure. The model should tell you, oh, you might be wrong.
Yeah.
And so let's build a mean model who always like puts you right on the track and tells you, I don't know.
I mean, if it's not 100% sure that it's either yes or no, then I don't know is so good. Because if that's like thinking how to implement it, then actually every like surgery or like every examination could be like started with it. So like just like every time whatever the input is, ask like is this brain looking healthy? Yes. And when you do test and actually it always says yes, and it's, you know, okay, it's gonna be 99 always like this. But if it's like very high score of accuracy of saying yes, it's healthy,
Yeah, then it will be trained to say yes, right?
yeah, I mean, but I'm talking about a good scenario. Basically, if we would say like yes and no, like very precisely, and then I don't know, maybe even like very often I don't know. It can be saying I don't know in 50% of the cases, but it's still, you know, cutting in half. Like you have like some kind of pre-selection or maybe whatever. You know, people are waiting long for any kind of doctors, especially in public healthcare. So this would be helpful.
But going back to this, what you said before, if it would say, I don't know because,
Yeah.
and I would need more information.
Oh, that's even better. You're getting...
Yeah, I'm getting ahead. Very optimistic. No, I am very optimistic. Thank you very much. That was very good and insightful.
Thank you as well.